Designing a suspension for the Lotus Type 111 chassis.
Okay.
And this is the load simulation that I'm doing, and this part here simulates the wheel.
The wheel pushing. The
wheel of the front wheel of the car.
Okay.
This simulates the brake caliper.
Okay.
So I put in the loads onto here, and then I found out where all the loads are.
Okay.
Now, I found that my upper pin has a lot of high loads on it, so especially back into here, and that's where the peak points are. So I've already redesigned that by increasing the size of the pin and did that. So what I'm going to do is I'm going to go through the steps on redesigning this portion, the spacer that I have, because that one's got also very high loads on it. So I need to redesign that.
So you're increasing the area that is getting
Right.
handled the whole load.
So here is that little piece in there, and it's got an awfully sharp corner into there. So what I will do is I will change the design of it by making it elliptical in shape rather than circular. So what I will do is I will draw an ellipse in here and get it onto here. And now what I need to do is I need to make it conform into there. And so, oops, I need to show my planes. So now I need it to go with this plane, and I want it parallel to that. So now it'll always be parallel to that one, and I also want this to be coincident with that, so that way it'll always be there. And I also want it, oops, that's not allowing me to do that. Yes, I can set up a distance here.
Now this is the program that most car manufacturers are using.
Yes, they all do. They all do now. No, I don't want to do that here. What I want it to do is I want it to be coincident with this one. Here we go. Alright, that gets me my size. Perfect. And now what I also want it, I want it to be tangent to here, and I want it to be tangent to this one also at the same time. But it won't do that. I can only do an absolute height, so 8, so I will do that as a if I set it right at 12, it'll work. Alright, perfect. So now I've got that set up onto there and that onto there. So what I will do is I will eliminate these and I will have it set up. So I want to trim it down to there and then trim that to there. And now I need to erase these since I don't have them. Since I won't be needing these anymore. Delete, delete, and delete. And this would actually be better as a circle also rather than that, so I will strengthen that by putting a radius on there. let's see, I want this thing to always be tangent. And then I can change this to 1 millimeter, and that should work very nicely. Let's go out of it. This is what it looked like before, and now when we refresh it, this will be the strength of it now.
So it will be so thicker and stronger.
Right. So now I made it stronger, but just in the minimum amount of places.
Ah, okay. So you compressed it. Looked like that you compressed it.
Right. Yeah, well, it's still put on a little bit of weight, but again, this whole thing only weighs 4 grams.
Okay.
That part is only 4 grams. So, anyways, now I've got that, and I want to save this, and that's what it takes in redesigning a small piece of the puzzle.
This is only a small piece. How about all designing, or let's say the whole engine design, or let's say the calipers design?
Well, right now I'm only working on the chassis, so let's show the chassis.
So you are designing the chassis too? You are modifying the chassis?
Yeah, do different portions of the chassis here.
Okay.
Suspension, where's my front right product? Here we go. So now here's where all the pieces all come together. So now I've already...
So this is the caliper. It's
Yeah, that's the
4
brake caliper.
pistons,
Right.
brake, and it's
This
built
brake
from
is-
titanium?
Only small portions of this are.
Oh, okay.
This is a forged aluminum. This is a special heat-proof aluminum. This is a very tough aluminum, so I'm specifically changing the alloys. So now if you take a look at these, you see how much bigger they are?
Correct.
So now I've changed the pieces, and now this is how it looks already assembled.
It was a smaller before. It was small.
Right, it was
Now
smaller.
it's getting bigger. Yeah.
Now we can update it, and that's how it all comes together. And this is actually larger. It goes all the way over the edge here of the part.
Correct.
So that should come out I've increased the size of this to the same size that it is on the bottom.
So it can handle the load. That
Right.
means there is no
So
failure.
I want to reduce the loads onto it just so it doesn't fatigue out.
Okay.
So anyway, then that's how the whole bits and pieces, how it comes together and looks at it. So this is what it looks like when it's all put together, and this is what looks like when I simulate the loads on it. In terms of all the bits and pieces are on here, but I need to put a load onto it.
Correct.
And that's how you do the
So
load.
you can measure exactly where's the load and
Right.
there's the okay.
So anyway, so that's how that works.
Yeah. Okay. Thank you, Mr. Jodel. Thank you.